Assalamu alaikum and welcome back. In today's class, we will be learning about simple coordinates. Now, coordinates for DSE's topic, we have two main types. One is called rectangular coordinates, or you could just simply call it coordinate, and the other one is called polar coordinates. Now, what's the difference between them? For simple coordinates, the rectangular coordinates, you will represent it by x and y. As for the polar coordinates, you will be kind of like drawing circles, but we don't really draw circles in DSE because that will take too much time and we don't have that much time. So instead, we will see these kinds of coordinates there. Now, what does that mean? The 4 here means the radius. Radius means from your pole, or you could say from your center to your point. That length is called radius. So for example, if there's a 4 here, that means from the center to this point, the length is 4 units. And then how about the degrees here? For degrees, we always start from 0 degree, go anti-clockwise, and then just keep on writing the degrees. And in the end, it will turn back to 360 degrees. So if the coordinate is, let's say let's say it's 5 and then to 30 degree. What does that mean? Let's say this is your X point. 5 means from your center to the outer lines, these lines, the distance is 5. But we decide on the length later. First of all, look at the degree here. It says 230 degrees. That means starting from your 0, we need to make a 230 degree there. Here, 90. And then 180. Then we still have to go. Now till the bottom, it will be 270 already. So that means that 230 is somewhere in this box. We don't have to be exactly the same degree. So just approximately, like around there. So it will be somewhere here. Even the length, you don't really have to follow it exactly. So it's around like that. This will be your X point. Now that's just kind of like BS. Of course, I will explain while we are doing question. As for the rectangular coordinates, the normal coordinates, we use X and Y to represent. And then before we continue, you need to make sure that you know where is which thing. So if this is your rectangular coordinate, this is origin. You need to know the name of this center point. We call it origin, using O to represent it. This is a 0, 0 point. And then on your right side, this is X, and it's getting bigger and bigger. That means on that side, everything is positive. Okay, and so on. On the other side, the left side is the opposite of it, so it will be negative. Okay, same goes for Y. For upside, it's positive. Downside, it's negative. Okay, now if I have a coordinate somewhere here, let's say this is our A point. What do I write for that coordinate? We will write the X coordinate first, and then comma, and then the Y coordinate. Now for X coordinate, because it's on this side, so we say, see around, it's around 3. So we write the X coordinate is 3. Oops. And how about the Y coordinate? We don't know the exact, right? Because it's not written there. So it should be around, let's say 4. So we write there. Okay, then next question. If I have a B coordinate, -7, -2, where do I put that? You will have to see your X coordinate and the Y coordinate. Are they positive or negative? The x is negative. So that means it's somewhere this side because all the x's are negative here. And then they say that the y is also negative. So the downside, the x is this side. That means this is your box. So B is somewhere here. You don't really need to follow exact thing. Okay. If you want to, you can still, because -7 is somewhere here for x, -2 somewhere here, and then you can draw a rectangle there. Okay, and that is where your B point will be. Okay, now we will use few more examples later on in the question so that you're 100% clear of the rectangular coordinates in today's lesson and maybe polar coordinates if we still have time, which is not really possible in within 1 hour, but let's see how it goes. Anyways, so that's just the basic thing that you need to know where the x and y is. Now, and there's also a thing called bearing, but not really common in DSE, just came once, I think. So for now, we will be skipping it. And I need you to go to, the tutorial 6 worksheet. So for coordinates, there's a lot of things that you need to remember as well, especially for the rectangular coordinates. Some of the things is called distance. You may need to use it. Second thing, slope. These are the very two basic things that you need to remember, the formulas for it. For distance, the formula is square root first, x2 minus x1 square plus y2 y square. For the slope, it will be y2 minus y1 over x2 minus x1. Now, what is this y2, y1, x2, x1? These things are basically your coordinates. For example, if I have coordinates, let's say, do I have example here? No, I don't. Okay, like this is a straight line here. We have an A point here. We have a B point here. The coordinates of A is x1 and y1. That just means the first x, the first y. The second x, the second y. If there's a C point, we will just call it x3 and y3. And if I want to find the distance of these two, the y of each of them, subtract, minus them, and square it, plus the x minus each of them, also square it, and then plus them. Okay? That's how we find distance. When we do the question, you will better understand the equation as well. As for the slope, same thing. You will have these two things. And if you want to find the slope, the second y minus the first y over the x differences. Okay. And then now, why do we need to focus on slope more? Because that's what the DSE usually asks about. Now, after finding the slopes, the question will be asking you few things, whether they are parallel or perpendicular. These two are the main things. For parallel, what does slope means basically? It's like your direction, whether it's going up, straight, or down. If it's going up, the slope is positive if it's going up. If it's horizontal, it's 0. And then if it's going down, negative. And then now what does parallel means? A line is parallel when the directions of it are going the same. So for example, what lines are parallel? Are these two lines parallel? No, because one is going there, one is going down. They are clashing somewhere. If I draw it longer, they're clashing. If they clash, that means they are not parallel. And they're not even going to the same direction, so we can't call it parallel. So, for example, this line. Both of them are going, will they ever meet each other? No. They are never meeting. They are just next to each other, same direction, but never really meeting each other. That is what we call parallel. Now, what's so special about parallel? Both of them, it's like that, okay? That means their slopes are same. So if you want to prove something is parallel, you just need to prove the slopes are same. What are these symbols? This is the basic symbol for representing slope. So you can write slope of line 1 equals to slope of line 2, or you could just use this symbol, slope line 1, slope line 2. How about if the question has perpendicular? That is a little hard, but the perpendicular is more often asked. For perpendicular, you need to find the slopes. Okay, first step, find the slopes of all the lines. Secondly, slope 1 times slopes 2. And if it equals to -1, then it is perpendicular. Now, what is this sign then? Perpendicular means there's a 90-degree in between them, the lines, okay? If there's a 90-degree, we call it perpendicular. And for the perpendicular, the slopes are basically opposites. So you multiply the slopes. If the answer equals to -1, we call them as perpendicular. So I'm multiplying line 1 and line 2. The answer equals to -1. Then I can say line 1 is perpendicular to line 2. Okay, I know that's too much, right? It is actually too much. So polar coordinates, we will go to it later. Now that's just for some notes, because I want you to do this one first. Coordinate geometry of straight lines. Everything is in that folder actually. Because this one have more basic things. And then you need to actually learn the rectangular coordinates starting from now. So let's draw first. By just looking at the question, you need to know whether it's a polar coordinates or a rectangular coordinates. Now, if you see, they just mentioned coordinates. And is there any degrees in any of the things? Nope. So that means this is a rectangular coordinate question. So just draw a symbol rectangular coordinate first. We know X and Y because it's rectangular coordinates. And then just guess where will these two be? This is A point, this is B point. For A, both X and Y is positive. So where will it be? It could be anywhere, right? Nah, it can't be anywhere. It has fixed point. We know that this X is positive here, Y is positive here. So this is the quadrant for point A. We need 6 and 9. X is shorter than the Y. So draw it something like that. This is, of course, a very, very bad drawing. I'm just trying to draw it like not exactly the same, but then it will be almost understandable. So let's say 6 here, 9 here. And then how about for B? The X is positive, the Y is negative. X is positive, Y is negative. So it's somewhere here. And then we know X is 3, so it should be somewhere here. And Y is -7. So you also write there. It should be somewhere here. -7, 3. So this is your B. 3 and -7. Now that is very important. You need to know the original points first, where they are, so that you can do the next question. Now what happens to A point? A point is here. It is translated. Translated in maths is basically meaning moving. So up, down, left, right, move it, move it. Those moving thing is what we call translated. Now, if it's say A is translated leftwards, So this is your A point. It is going to the left side now. How many steps is it going? It is going by 14 units. So it starts from this X point, 6. It goes to the left side. How many points? 14 points. And then where will it land to? That's what you have to find. How about your Y point? Will it change or not actually? Now you're just moving like that. Is your Y changing? Because you're just going to the left side. No, the Y is still here. There's no change of the Y's. Okay, so Y will still be 9. Just the X is changing. How much does it change? You start from 6. 5, 4, 3, 2, 1, 0. So 6 steps here. Now, how many more steps do you need? In total, you have 14 steps. So 14, you already have 6 steps. So that means it will be coming to somewhere with 6 steps here. And then you still need 8 more steps. Because in total, you're going 14 units. So your next point, A naught, will be somewhere here. So your new A will be -8 and 9. Be careful, the Y is not changing. You're just moving to the left. You won't suddenly get short or tall. Okay, Y no change, just the X. Why is it -8? 6 steps here, 8 more steps here. Now this is 0. Afterwards is -1, -2, -3, -4, -5, -7, -8, like that. It's -8 point. So make sure you get this correct as well. And then how about B? What is happening? This B, original B, is translated. So translated means moving. Where does it move? It is moving upwards this time. So the height is changing. It's moving upwards by how many steps? 5 units. So it's originally here. It will go up now. How many steps are we going? We are going 5 steps. So will our X change? No, because you're just here, you're just going up. You're just going how many steps up? 5 steps. You were at -7. You're going up 5 steps. Where would you land at? You can count one by one. -6, -5, -4, -3, -2. So 1, 2, 3, 4, 5. So that's where you land. So your new coordinate for Y, but this time you're going up and down. So your Y is changing to -2. So our new B is, the X won't change because you're not going left and right, but that is changed. So that's your new A and new B. This is 2 marks already. And the finding slope is another 2 marks. How do we find slopes? And we need the slopes of these 2 points together. So that means there's a straight line. This is oh wait, the new B is here. So this line here, we need to see how down it's going. Now, at least we know it's going down. If it's going down, your slope will be negative. So if your answer you did not get negative, that means you did something wrong. Okay, let's find the slope. Slope is the Y's minus the Y's over the X minus the X. So the Y's minus the Y's over the X minus the X. So it's -2 here minus -9 here over the X's 3 minus -8. And then the upper side, do it separately in calculator and the downside as well. You'll have -11 over 11, which is -1. So we just know the slope of this thing, or it's better that you write it this way. Slope A dot B dot. The slope of A dot B dot is this one, -1. Nothing special here because they did not ask you to find anything else. They could actually, they could ask you a lot of things in this question. Okay, so that's the first style of coordinates where you will be translated. That means moving up, down, left, right. It could be anything in your question. The second thing that they can ask is about reflection. And the third thing is about rotation. Now for reflection, where would you see your own reflection first of all? Do you just see reflection everywhere? Can you just look at your pillow and say, oh, I can see my other pillows?
No.
Ayla, so where do you see your reflection?
Mirror.
Yep, mirror. And in your reflection, will you suddenly grow tall, grow short, grow thin, grow fat like that?
Nope.
Nope. So basically, everything is just in the opposite way and you won't change much things. So let's also draw the original points first. You can try to draw it. Give you 20 seconds. Draw first. Because drawing is the hardest part actually. P first and then Q. They're literally fighting for the votes outside. Did your parents go and vote? Oh, continue. So in this graph, where's the P and then where's the Q? 1, 2, 3, 4. We call these quadrant. So quadrant 1, 2, 3, 4. Where will this P be first of all?
Two.
Here?
Oh. No. Right side down.
So 1, 2, 3, 4.
4.
Yes, good. So P is there. How about Q?
3.
Yeah, good. And then what's happening? P dot, the new P, is the reflection image of P with respect to the y-axis. What does these all things mean? P is here. Now it's reflected to this point. But how is it reflected? Where is the mirror? We need to find that mirror. The mirror is here. When they say with respect to something. If they say y-axis, that means our mirror is here. This is our mirror now. You are standing here. Where would you go to? If this is our mirror. We go to the opposite side of the mirror. That means here. Okay, that's how the mirror image are formed. Just basically the opposite sides. Now, could you be here? The mirror is here and go up? No, that will be translation. But if you're exactly on the opposite way, we call that reflection movement. As they say y-axis this time, so the mirror is here. If next time they say x-axis, then this will have been your mirror. Then you're here and go there. So what happens? So I know that if originally is there, now it's coming to here. Then what about my coordinates? Is my height changing? Nope. That means my y coordinate is no change. How about the x? Originally, it's 11. That means from this point to this point here, we have 11 steps. So your distance from your point to the mirror, it's 11. So the mirror and the object distance has to be the same as well. So if it's 11 here, it will be 11 there as well. So that's why our coordinate is -11. Basically just the opposite, because the mirror is right exactly in the middle. It could be somewhere else, like not just x-axis and y-axis. Maybe there are questions. They ask you that the mirror is here, then you need to find the distance from here to here. Then you need to go the same distance there at the end. Still, the height is not changing, so no change for the y's. So write that first. Your new p is -11 and -6. How about new q? What happened to that? That is rotating. Now, rotating is very interesting because students get confused. First of all, what is a clockwise? Clockwise means something that is following the clock direction. So if you get confused, I will suggest you to draw the clock. So if you're going to that side, the right side, it's called clockwise. And then the other side is not following the clock. 11, 10, 9, you're going that side. It will be called anti-clockwise. That's the first thing. Next thing, why is there a degree here? So, do you see there is something special in this line here? There's a 90 degree. So each box is 90 degree. Okay, we remember it that way. And then now they are saying Q is rotated clockwise. How many degrees? 90 degrees. So Q is here. It's going clockwise. That means there. Okay, clockwise is like that. Okay, so here, going clockwise, how many boxes? Each box is 90 degree. And then we just need to do 90 degree. So just one box. And then every 90 degree, you rotate the numbers as well. Every 90 degree, rotate the numbers as well. What does that mean, Miss? That sounds so weird already, right? So originally Q is here. Now you're rotated 90 degrees. So it goes there. So if it's 8 and 15 here, going to next box, it will be 15 and 8. Okay, write the numbers first. 8, 15 goes there one box, rotating one box, so you rotate the number ones as well. So 8, 15, turn to 15 and 8. After the numbers, you also need to decide whether they are positive or negative. Because if it's in this box, the X is negative. So you also put negative sign there. And then in this box, the Y is positive. So make sure your Y is positive. So that is our new Q. Okay, this one should be a little hard, but how about for part B, slope? Can you try to find that? How would you find the slope? You have 2 points. The points are here. To find the slope, it will be the differences of the y's over the x. So you've tried to find it first. Give me 20 seconds and let me know what you thought.
(14/-4).
Yeah, simplify it. You will click calculator.
(-7/2).
Yep, that's correct. Oh, Okay, this one, I want you to try on your own. Give you 1 minute to find the new C and the new D. C dot, D dot. It's a small dot there, that's why. Oh, kayo. It's a must-come topic. 5 marks, 4 to 5 marks. You can tell which quadrant they are in.
C is gonna be on the third one. And then D is gonna be on the second.
X is positive. For C, X is positive, so it should be in
Fourth?
fourth. And then D is correct. So somewhere here. And then also for D. And then where's the new C? Reflection along the x-axis this time. So this is your mirror now. So usually I draw a rectangle because if it's mirror, it's easier to see. That would suddenly just become like this, just the opposite of it. That's your new C. What's the coordinates? Is your X changing? This point is 30. The X is not changing, but the Y is changing. Originally, it's at the negative side. Now it's going to the positive side. So what's your new C?
30 and 15.
Good. Yep. How about
And then,
D? That is hard. Anti-clockwise, be careful. So each box is 90 degree. If I had to come to this box, it will be 25 and 20. But since I need 180 degrees, that means there are 2 boxes. So 180 divided by 90 is 2 boxes. So I need to go 1 more box. So also here, when I come here, it again becomes 20 and 25. And then after writing the numbers, I need to decide whether it's positive or negative. On this side, X is positive, Y is negative. So I put a negative sign to the 25. So every 90 degree, you switch the numbers. And because I need to make this 180, so another 90 degree. So switch the numbers with the previous one again. So that is your latest D.
so if it's like 360 degree, it's gonna be on, like it's
1,
gonna move another box.
3, 4.
Oh, okay.
And then if it's 360 degree, that means it's coming back to the original point.
Oh,
So
okay.
how about if they say 270 degrees?
moves to a box.
Each box is 90. So you do, no matter how many degrees, divide by 90. Okay. Or what if it says 540? So 90, 90, 90, 90, 360, 90, 90. So 540. 540 will be 540 divided by 90, you get 6. So you need to move 6 times 1, 2, 3, 4. 1, 2. Oh,
Oh, so like whatever number we get, we have to move that much. Like if we get 6 or 2, then we have to move 2 boxes.
yeah.
Okay.
So you got your new C, your new D. What did you get for slope? You can find that as well.
-4.
Yeah. And -4 or +4?
Oh, I got -4. I think I did wrong.
So -25 minus 15. And then 20 minus 30.
Yeah, now it's correct.
Oh, next one as well. Give you 2 minutes to finish until at least part A, as we need
Okay.
to learn this. Continue back. So new A, new B. Original A first. Which quadrant? What happened to A? A is rotated anti-clockwise. How many boxes? Just one. So A is here. Anti-clockwise. Let's see. Do you fall to the trap or not? Which side is anti-clockwise now?
Left.
That means going up or down?
Down.
So you mean it's coming here?
Yeah.
Haha. Draw the clock.
Oh yeah. Sorry.
Yeah.
The
So
other
around
side.
here, and the clockwise will be going there. It's very important to draw everything, or else we won't understand easily.
So during during DSC, we have to draw first to know the exact thing. Oh, okay.
Without drawing, unless you have done like 5,000 of same questions, then you don't have to draw, or else better draw it.
Okay.
So you know A will be here, new A is here, because it's just one box, 90 degree. And then every 90 degree, we switch numbers. It was 4 and 2, now it becomes 2 and 4. Did I draw something wrong? Yes, I did. Oh my God, so stupid. But yeah, the A is not here. A is X is negative, Y is also negative. So it's in this box. So it's in this box. And then it's going that side because it's rotated anti-clockwise. So it comes here. 2 and 4. And then now we have to decide what happens to the x and y. The x here is negative. So put a negative sign. Y is positive, so no change. How about for B? What's happening to that? B is translated leftward. So B is going to the left side. How many steps?
10.
10 higher. So where it is originally, it's here. And it's going to the left side, 10 steps. How many steps here already?
3.
Yes, 3 steps here already. How many more to go?
7.
Yep, 7. So it will come somewhere here. 7. -7. So that's your new B. Will your height change suddenly? You're just going to the left side. So no, height will not change. So it becomes -7 and 5. You have all the coordinates now. Now what's the question say? Is AB perpendicular to new A and new B? How do we know if something is perpendicular? Perpendicular basically means there is 90 degree. Does it look like there's a 90 degree? Maybe, because our drawing is not so pretty at this moment. Maybe there is a 90 degree here. But of course, it's math. We can't just draw and then let them know because markers are too dumb. They don't understand the mark drawing sometimes. So we need to use numbers. First of all, find the slope of AB. And then find the slope of A dot B top. And because we need to prove if it's a perpendicular, so multiply both of the slopes. If it equals to -1, it is perpendicular. So what do I mean? Find the slope of AB first. A coordinate and B coordinate is here. And then to get less confusion, let's rewrite the coordinates so that's easier to look at. It's just one question. So how do I find the slope? The y's minus the y's over x minus the x. So the y's minus the y's over x minus the x. Negative, negative becomes positive. So 5 plus 2, 7 over 7, which is 1. Lucky, good numbers. Oh, the screen is so slow. See. Hey. So yeah, you find the slopes and see what do you get for AB first. And then also find the slope for the new one. Because your new A is -2 and 4. Your new B is -7 and 5. And then find the slopes of them two as well. And see what do you get. Something is going wrong. So what do you get? 7 short. So 1 over -7 plus 2, -5. And then we need to see if they are perpendicular or not. Okay. Okay, I found a mistake. Anti-clockwise, oh my God. This is clockwise, right? Going like that, clockwise. So that means the A is wrong here because we need to go anti-clockwise. So if it's here, we need to go that side. So this is wrong here. And now how do I know if it's wrong? Because I could not, after multiplying by these two, I could not get a -1. But the question said that it's perpendicular. So it has to be -1. And since I could not get it, that means I did something wrong in the question. And the wrong part, usually it's the anti-clockwise and clockwise. So that side is a clockwise. I need to go this way. So my A was wrong there. Okay, that is a wrong direction. Anti-clockwise is here. So this is your new A. Continue. So because I did the wrong direction, anti-clockwise should be here. This is your new point, not that. Okay, your new point is 2 and -4. So your new point is 2 and -4. 2 and -4. So let's see what do you get now. It's 3 on top, -7. So you get -1 there. And then to prove if something is perpendicular, you multiply their slopes. And if it equals to -1, it is the answer. So you multiply AB slope with the new AB's 1 times -1. And what do you get? And if your answer, you can get a -1, we can say that they are perpendicular to each other. Okay, the network is having problem. All right. Ooh, nothing is working here. So what we did previously was bad because it was anti-clockwise. But we need to make sure that it goes to the anti-direction. It's actually to that side, not this, because that will make a perfect clock. So we go the opposite way. So that's why our new A was actually there. And then why I know it was wrong, because after multiplying them, it was not coming out -1. And if it's not -1, it's not perpendicular. That's why we have to check each time, a few times actually. This is a very confusing topic, and then you need to be super calm while doing it as well. So after finding all the coordinates, see what the part B question needs. This is the most typical question actually. Finding the slopes and see whether they need perpendicular or parallel. If they need perpendicular, you multiply the slopes. And if the slopes after multiplying, it equals to -1 in the end, then they are perpendicular to each other. Basically just copying down the sentence. Now, how about, okay, do a very same question 6 first, and then we'll do the parallel as well. We will finish the long question at least. Oh, quickly do this one, question 6, 2 minutes. 2 marks here, 3 marks here, finding the slope of this, 1 mark, finding the slope of this, 1 mark, and then the proving. Quickly draw. You don't have to be very pretty. This is C, this is D. Oh, both are on the same side. That means you need to decide whether no, you don't have to follow the exact same thing because it doesn't usually matter. Just if you want a very pretty one. C is 3 and 6. How about D? 2 and 5. What happened to C? C is reflected. That means there's a mirror. Mirror is at the y-axis. This is your line. You are here. So after using the mirror, you will be the opposite side. You will be here. That's your new C, which is the height won't change because you're just going to the opposite side. So the height is still 6. And the x, the opposites. And what happened to the D? How many boxes is it changing? It's just changing 1 box because just 90° there. It's originally here, clockwise. Okay, this time we are fine. Clockwise, just going down. How many boxes? Just 1 box. And then every 90°, we switch numbers as well. After switching numbers, we need to decide whether it's positive or negative. X here is positive, so that's fine. Y here is negative. Okay, so you found your new C. You also find your new D. And then what does the question need? We now need to prove whether they are perpendicular or not. So to prove something perpendicular, find your slopes first. So you find the slope of CD first, and then find the slope, find the slope of C dot D dot. And then to prove if they're similar or perpendicular or not, you multiply them. See what do they equals to? If they equals to -1, then we write CD is perpendicular to new C, new D. Okay, easy. Then let's continue. Original C and original D is here. So their slope, the y's minus the y's over the x minus the x. And then the new CD, the y's minus the y's over the x minus the x. And now the slopes have to multiply each other. One times -1. It is equals to -1. And if it is equals to -1, we say they are perpendicular to each other. If this is fine, very quickly do the previous question. Parallel. Parallel means the slopes are same. So again, you find the new coordinates. You find these two slopes. If they are totally the same, both of them, the final answer are totally the same, then we say they are parallel. So you find the new P and new Q first. See what do you get for that? Original first, -1, -4. And then Q What happened to the P? P is rotated anti-clockwise to the new P. So anti-clockwise this time, we won't fall to the trap. We do actually. Anti-clockwise is that side. And how many boxes? One box. Just one box. And then every 90 degree, we switch numbers. Because on this box, the Y is negative. So you also put a negative sign there. How about for Q? What happened? Q is translated. Okay, translated means moving. So moving, how many? Downwards. So how many steps downwards? 17. So how many steps does it originally have from up to here? 4. How many more steps does it need? 13 more, because we need 17 in total. So it will be at negative 13. And then, of course, it's not suddenly getting thin or fat, so the x is not changing. After finding the coordinates, then we quickly do part B's as well. Find the slope of PQ. Find the slope of P dot Q dot. And then are their slopes equals to each other? If they are equal, then we say PQ is parallel to P dot Q dot. So PQ first, that means the original ones. The Y minus the Y over X minus the X. So 8 over 2, which is 4. And the same goes for the new P's and new Q's. The Y's minus the Y's over the X minus the X. So negative 12 over negative 3. Also 4. Yee. Luckily, they are the same. So you write because this is same as this. They both have 4. So this thing is parallel to this thing here. PQ is parallel to P dot Q dot. So that's the basic types of rectangular coordinates. You will be given the original things, and then you might have to rotate it, reflect it, or even translate it. So any of these options, and then afterwards you find new coordinates. And then part B is usually using either of the 2 points, find their slopes. And if they're asking you about parallel, that means they need you to have the same coordinates. If they're asking you to have perpendicular, that means you multiply the slopes and it equals to -1, then it is perpendicular. But if it does not equals to -1, it is not perpendicular. So, okay. So that's it for this much. And then I will want you to do coordinates DSE questions. Go to long questions actually. You will see these are actually DSE questions. Same thing, you have some points. What's happening, like rotating, clockwise, 90-degree, reflection, which part, why? And then are they perpendicular or not? You do that. So we do all the rectangular coordinate questions at home. Coordinates. That means these common ones. And then next lesson, we will do the degree ones. That means the polar coordinates. That is much harder, actually. Much. So you do all those, okay, rectangular coordinates ones. There's a lot, actually. And they are actually asking the same thing. It's just practice makes perfect now. DSE repeat questions. So make sure you do at least 10 years of past papers. Yeah, this was too easy, 2022, because it's just a simple thing and just ask you to find the slope. This should be 3 marks, but then they still were nice enough to give 4 marks. And 2023 did not have it. So that means it's 100% that 2024 will have it. coordinates. So make sure both rectangular coordinates and polar coordinates are 100% clear. This is rectangular coordinates, and next lesson we will do polar coordinates. So any other questions? Do the questions at all? If no questions, then we will end the class here and continue polar coordinates in next class. So if no question, we will continue the class next lesson and see you next time. Bye bye. Allah Hafiz. Allah Hafiz. Allah Hafiz. Allah Hafiz. Allah Hafiz. You get out of the video. Allah Hafiz. I will be like that, but I don't know for how long. Allah Hafiz. Okay, I have to end now. Allah Hafiz.